Okay, so we've sort of started talking about properties, and there's really two main ones that we're going to talk about. The first one we're going to talk about just briefly is the commutative property. The commutative property essentially says you may add or multiply in any order, and it's not going to change your answer. For example, 6 plus 2 is the same as 2 plus 6. You probably learned that in elementary school. I'm sure you did. And the purpose for that, what really helps with that is if you have a bunch of numbers that you're adding, for example, 23 plus 14 plus 26 plus 37. If you're adding, for example, something like that, instead of saying 3 plus 4 is 7 plus 6, so forth and so on, it's easier to make groups of 10 if you can. So 7 plus 3 is 10, 4 plus 6 is 10, so that together is 20. Carry the 2. 2 plus 2 plus 2, so 2, 4, 2, 4, 6. And then plus 1 is 7, plus 3 is 10. You actually get 100 from that. But being able to think about changing the order and not having to do the numbers in order when you add makes it a little bit easier. It also makes it easier when you're multiplying because you can look for numbers that are easy to multiply. Now you could multiply this one straight across, 32 times 5, but a lot of people can't do that in their head. What a lot of people could do in their head is if they rearrange this problem, do 4 times 5 times 8, because 4 times 5 is 20, and 20 times 8 is really easy to do in your head. You get 160. Or you could even rearrange that one to do 8 times 5, or 5 times 8, and then times 4. 8 times 5 is 40, times 4 is 160. So that's the purpose of the commutative property, just to change the problem around. And usually you want to change it so that you can somehow make powers of 10, because that's going to make them easier to either add or multiply. Now the other property that we're looking at is the distributive property. And the distributive property says that when you are multiplying a number by either an addition or a subtraction problem, there's more than one way you can do it. You can either follow the order of operations, which is what you've mostly probably all been taught to do, or you can multiply by each of the numbers in the addition or subtraction problem, then add or subtract the products. So for example, what it's saying is most of you probably would think to do, well, 5 plus 4 is 9, and then 6 times 9 is not 36. 6 times 9 is 54. You could do that. But what you could also do is you could multiply 6 times 5. So you could think of this as 6 times 5, and then 6 times 4. And then whatever symbol is between them, in this case it's addition, just bring that down. So 6 times 5 is 30. 6 times 4 is 24. 30 plus 24 is 54. We get the same answer. Now you might be going, what in the heck? Why would that possibly be something that I would want to do? It really doesn't look any easier. Well, there's a reason. There's always a reason. Let's say we wanted to do 8 times 36. We could really rethink that as 8 times 30 plus 8 times 6, because what I'm doing there is I'm thinking of 36 as 30 plus 6. So if I want to do 8 times 30 plus 6, I could think of it as 8 times 30 plus 8 times 6, because all I'm doing is I'm distributing. I'm distributing the 8 times the 8 to the 30 and to the 6. So 8 times 30 is 240. 8 times 6 is 48. So I get 288. I could do, for 5 times the sum of 10 and 7, I could rewrite that as 5 then times 10 plus 5 times 7. And so that gives me 5 times 10 is 50, 5 times 7 is 35, and 50 plus 35 is 85. What I've really just done is 5 times 17. Another example, if I wanted to do 43 times 6, if I rethink the 43 as 40 plus 3 times 6, then I can really think of this as 40 times 6 and 3 times 6. Notice it's the number on the outside that has to be distributed to each of the add-ins in the inside of the parentheses. So 40 times 6 is 240, and 3 times 6 is 18. So 43 times 6 is equal to 258. And I've done that multiplication in what might be an easier way if you wanted to do it that way. So I could rethink 62 times 7 as 60 times 7 plus 2 times 7. So that gives me 420 plus 14, which is 434. This even works with algebra. If I have 7 times m minus x, I can really look at that as 7 times m minus 7 times x because I'm distributing the 7 to the m and to the x. So similarly, if I have 6 times r minus 4, I can do 6 times r minus 6 times 4. Now, can I solve those? No, but I could rewrite the second one as 6r minus 24 if I wanted to rewrite it that way. I certainly could. So why in the world would we possibly want to know this? Well, the biggest reason is because it helps us with mental math. Can you do 7 times 48 in your head? I can't either. Probably most of us can't. But what I can do in my head is 7 times 40, which is 280, and 7 times 8, which is 56. And when I add those together, I get 336. So I can do that in my head and keep all that straight, and really it helps with mental math. That's where we usually use this. So if I look at a couple of examples, I can use the distributive property to simplify these. So try them yourselves and then see how you did. All right, for the first one, you could have done 6 times 20 and plus 6 times 3, which is going to give us 120 plus 18, which is 138. For the second one, you could do 9 times 10 plus 9 times 7. 9 times 10 is 90. 9 times 7 is 63. So 90 plus 63 is 153. Again, notice the problem that I've done in my head is 9 times 17. That's the problem that I did in my head. For the first one, the problem that I did in my head was 6 times 23. For this last one, 80 minus 5 times 2. I can do this with subtraction as well. It works the same way. I'm going to get 2 times 80 minus, because it's a subtraction sign, 2 times 5. 2 times 80 is 160, and 2 times 5 is 10. Whoops. 60 minus 10 is 150. What I've also could look at this as is 75 times 2, because 80 minus 5 is 75, and then times 2. Just a couple more examples. What I'm really going to be solving with this first one is 8 times 47, but thinking about it the way that it's written up here makes it easier to solve. 8 times 40 is 320. 8 times 7 is 56. 320 plus 56 is 376. This one is going to end up being 52 times 6, the answer to that problem. So I could do 6 times 50, which is 300, and 6 times 2, which is 12. So 300 plus 12 is 312. And for the last one, I'm doing 11 times 61. 11 times 60 is 660, and 11 times 1 is 11. So I get 671. And really, it makes the mental math so easy if I am able to use the distributive property to do that. And that's really the biggest benefit of using distributive property.